JSON Web Token. It's a JavaScript library. It is being used by plenty of web applications across the globe. Recently, a critical code execution vulnerability was found in the JSON Web Token library. And once they have announced that vulnerability, there were a lot of buzzes and speculations were going around. And this video is going to be a curtain removal one, where I'm going to explain about this vulnerability. And recently the Auth0, who is managing that JSON Web Token, came up with an update that they have retracted this vulnerability. So there are a lot of things happening, and I'm going to explain about this vulnerability here in this video. So stick with me, it's going to be an interesting one. And Unit 42 has come up with the entire update. They have recorded everything related to that vulnerability in a single blog. So I'm going to use this specific blog in order to showcase this vulnerability. And you can see the Unit 42 page here. The Unit 42 is an excellent excellent team who works on the cybersecurity stuffs, and they comes up with a lot of excellent, beautiful, incredible blogs around the information security. And you can see the recently launched blogs here and its reach, and you can see the number of people reacted to every blog. From that, you can understand the specific blog that I'm going to talk gained more attention. Around 80,000 people reacted to that blog because it was a popular one. A lot of people were talking about this, and I'm going to talk about this one. So you can see the update that was recently launched. Update launched yesterday by the Auth0, and this is the blog that was released earlier, and it was released on Jan 12th by Auth0. So Unit 42 recorded the entire stuff here. So let's go through and understand what sort of bug it is and why they have retracted this vulnerability. Well, let's read through this. Unit 42 researchers discovered a new vulnerability in popular JSON Web Token open source project, and another reason for its popularity is it is open source. It can be used by anyone. If you are developing a web application, then you can use this JSON Web Token library. And this vulnerability is identified as, so here is the CVE ID. Later it was retracted, but earlier this was the CVE ID given to this vulnerability. And you can see the high severity rate they are given here. It is only 7.6. Since, though it is a critical one, still they gave 7.6 because there were some prerequisites to exploit this vulnerability. And later they have found the hacker has to do a lot of stuff to exploit this. Then they have retracted this vulnerability. So let's understand everything here in a moment, but let's read through this now. By exploiting this vulnerability, attackers could achieve remote code execution on a server verifying a maliciously crafted JSON Web Token request. So this is the spooky thing about this vulnerability, and this vulnerability requires several prerequisites in order to exploit, and which makes it less likely for an attacker to use it in a wild. So in early time itself, they have decided that since there are a lot of prerequisites, it will be so difficult to exploit. And you can see the infected version. So the impacted version is JSON Web Token 8.5.1. So let's search for this JSON Web Token library in Google, and let's go to the repository present in npm. So here you can see npmjs.com. that is the official site where the npm libraries can be witnessed, and you can see the JSON Web Token, the pertaining library, and here is the command that you can use to install this library, and it is very simple. You have to install npm first, then you can install whatever library you want. And let's look at this versions folder, the tab. So when I click this, I can see the list of versions available for this library, and the version till 8.5.1 was vulnerable to this secret poisoning vulnerability, and they have fixed it in the 9.0 version. And you can see the number of downloads in last 7 days. There is a reason why I am saying it is very popular one, because you can see the number of download counts here. It is very popular. It is used by plenty of researchers, developers, and the enterprises who are running the web applications. And And you can see the version here. So this is the vulnerable version. You can download even the vulnerable version if you want. And I'm again going to the README, and here you can see the documentation that gives the functions involved in this specific library. Well, let's move on to the next one. JSON Web Token is an open source JavaScript package that allows you to verify and sign the JSON Web Tokens. So here is the crucial stuff. The main role of this JSON Web Token is to verify the access request. When a user access any web application, any authenticated or unauthenticated access, so it will be sending the JSON Web Token in a cookie place, like, so it will be getting that cookie and it will be verifying that cookie with the already stored secret. So that is how it functions. So you can simply keep like that in your mind. So it does the verification verification, and when someone claims to be this user, when someone claims some privileges, then this JSON Web Token verifies whether the user really possesses that privilege, whether the user really possesses that user ID or not. So that is what the role of this JSON Web Token. That is the major, the major use of this JSON Web Token, which are mainly used for authorization and authentication purposes, as I just now mentioned. Developed and maintained by Auth0. So Auth0 is the entity firm who maintains this JSON Web Token, and the package had over 9 million weekly downloads at the time of writing. So the count changes, and over 20,000 dependents according to JSON Web Token page. This package plays a big role in authentication and authorization functionality for many applications. Well, look at this, the titles and the synopsis. So I'm going to explain one by one. So here is the JWT 101. If you have no idea what is JSON Web Token, so this part is for you. JWT is an open standard that defines a method of transferring information securely by encoding, signing JSON data. JWT have a string structure that consists of 3 parts separated by a dot, a period symbol. And you can see the 3 parts here. So these are the parts. The first part before the period denotes the header, and the middle part denotes the payload, and the third and last part denotes the signature. And though the JWTs are used to transmit different types of information, its main purpose is to verify the claims. When someone claims to be this user, when someone claims certain privilege, as I said before, it verifies that. And in practice, this will most likely contain useful information about a user. And yeah, so mostly it is used to verify the user who are accessing that web application. Well, so this is the structure of this JWT. Now let's look at the JWT header, and in this header part, this first part they have explained here. So here is the decoded part of the header, and as shown in the figure 1, the header consists of mostly 2 parameters that indicates the type of the token and the signing algorithm. And you can see the signing algorithm given here, HS256, and the type is JWT, JSON Web Token. And there is a website called JWT.io, and you can verify the JSON Web Token here in this website, and you can encode and decode the tokens here in this. So look at this one. So here is the token, JWT, JSON Web Token, and you can see the first part, header, and the middle part, payload, and the third part, signature. So it is given here, and they have splitted all the 3 parts and they have given here. And you can see the color, it is highlighted in the color. The first one is the pink, second one is the a violet shaded pink, and the third one is the blue, sky blue. So these are the parts. So this is how it encodes actually. So this part is the decoded one, this part is the encoded one. And let's see the second one, JWT payload. And this payload is the second part of the token, which will contain the claims. In most cases, this will provide the useful information about the user. So this is the part where the detail about the user and the user's privilege has been mentioned. And you can see whether the user is admin or not. It is mentioned here, and also the username. And let's see that here. So here they have mentioned the name and IAT, some random identifier, unique identifier. All right, moving to the next part. These are the 3 different parts: claims, registered, public, and private. And actually there are 3 parts in the claim itself. can find more information about this. So there is a link they have given. So I'll update this link in the video description, so you can feel free to go through this entire blog once again, so that you'll be able to understand it in a better way. So the header and payload are each base64 URL encoded to form the first and second part of the JWT string. And you can see the first and second part they have given here. And they also mentioned that the header and payload are each base64 URL encoded. So that one they have clearly mentioned. And now we are going into the third part, the signature part, how the signature has been formed. So in the signature, in this JWT, there was a signature part, right? So how it's been formed. So that's what that is what they have given here. And look at this. The third part of the JWT signature is then computed by following formula using a secret key. So they are using a secret key in order to compute this specific signature part. So since they are using some certain secret key to verify this, to compute this signature, so it is difficult to forge this JWT, JSON Web Token, and that's why it is being used one of the trustworthy libraries to verify the user and their privilege. All right. A signature is used to verify that the token is not forged or manipulated. So this is the main thing here. Because it is signed with a secret key, we can validate the authenticity of the sender. Here is an example of the signature calculation, and they can give the whole formula that is used to calculate this third signature part. And you can see the base64 URL that is actually containing certain stuffs here. HMAC SHA-256 looks like a hashing algorithm, and the base64 URL, they are converting that header, the base64, they are converting that header into the base64 URL format, and they are giving it to the HMAC SHA-256 hash function. And you can see they are separating this header and payload. Both are base64 encoded, base64 URL encoded form, and they are separating it with the period symbol. And also they are mentioning the secret key here. So this is the entire structure. This is the whole thing. Base64 URL encoded header, URL encoded payload, base64 URL encoded payload, and secret key. So they are using all the three things, and the base64 URL encoded header and payload separated by the period, and they are giving it into the HMAC SHA-256 hashing algorithms. It eventually gives you this specific signature content. Now, once you obtained all the three stuffs, it is combined together and separated by the period, and it is given to the user as the JWT token, or the user gives this token back to the server in order to claim a certain privilege or certain user. Well, this is what the dissection of the JWT, JSON Web Token. And now they explained in few steps how this JWT authentication functions. Now, without reading this the line by line, let's see this image to understand it better. So look at the first step. There is a web application. The user is giving username and password, the credentials. And the second step, HTTP authentication request sent to the server that is issuing the JWT token. So before giving request to that specific web server, it is actually sending that request to the JWT server. That is where the JWT is being validated, and it will be generating the JWT token for the user, and it will be sharing the token to the user. And once the user is validated, it is serving the JWT token. So once the user got the JWT, they are giving the request to the website along with the JWT token. And once the JWT token is validated by the web server, it is granting access to the protected resources. So that is how this JWT authentication functions, and this image explains this JWT authentications in an incredible way. Well, let's go to the next one. Open source projects help a lot of organizations to save time and other resources. At times, this can serve as an elegant and quick problem solver. JWT became a very popular technology that many organizations rely on, and this is one of the great reasons of some open source projects implementing JWT have become a great success. One such project is well-known JavaScript solution signing, verifying, decoding JWT named JSON Web Token. This tool is developed and maintained by Auth0, part of Okta. Well, till now we have been trying to understand the JWT, the format of the JWT, and the authentication based on the JWT. And now we are getting into the vulnerability, and here is the CVE ID. CVE-2022-23529. That is the CVE ID initially given to this flaw, and later they have retracted it. Well, let's get into this vulnerability and understand it better. Typically, attacks on JWT will involve different forgery techniques abusing buggy JWT implementations. This kind of attacks have severe consequences because in most cases, a successful attack allows an attacker to bypass authentication, authorization mechanisms to access confidential information or steal and or modify data. One of the methods provided by JSON Web Token package is verify. And if you want to understand the verify method, they gave the hyperlink. So I'm trying to open the hyperlink. Let's see what we are getting here. And look at this. Here is the GitHub page of the JSON Web Token where they gave the explanations to each method that is in the JSON Web Token library. And you can see the JSON Web Token library and the verify method. And look at this. There are three arguments passed within this method: token, secret or public key, and the third one is options or callback. Now, before getting to this, so let's read this line once. The verify method receives three parameters: token, secret or public key, and options. That's what they are given here. And the function verifies the validity of JWT and returns the decoded payload part. All right. This verify function, actually the role of verify function is to verify the token that is given to it. And according to the documentation, secret or public key is a string or buffer. We can see the lines of code shown in the figure in the JSON Web Token verify.js source code. All right. Now they gave a code snippet here. And before that, we need to understand what is the verify.js, verify function is all about. And also, what about this secret or public key argument, which is actually the second argument of this verify method? They are mentioning it is a string or buffer. So let's see what it is. And look at the definition here. First one is the token. It's the JSON Web Token string that we have seen before. There are three parts in that. So that is the token. And along with the token, secret or public key is given. Secret or public key is a string UTF-8 encoded buffer or key object containing either the secret of HMAC algorithms or PEM encoded public key for RSA and ECDSA. So actually this one is the elliptic curve Diffie Hellman, like the cryptographical algorithms, and RSA it's another cryptographic algorithms, and PEM is the certificate file, and HMAC is the hashing stuff. So looks like with this parameter they are trying to verify the authenticity of the JWT, the key, the user. And if JWT verify is called asynchronous, secret or public key can be a function that should fetch secret or public key. So they gave the detail about this, the algorithms they have given, the list of algorithms: elliptic curve algorithm, RSA algorithm, secrets. So you can see the secret, and here you may see the algorithm mentioned in the JWT site. It is HS256, and it is one of the secrets given here. So it looks like this specific secret or public key is used to verify the authenticity of the user and the JWT. And the third one is option. It is containing the algorithms, and you can see it is listed here. And yeah, so this is what they have given. And what they are trying to say, according to the documentation, secret or public key is a string or buffer. We can see the lines of code shown in the figure 5, and they gave the code snippet from verify.js. So I have already mentioned it. So this is the code snippet. So I can show that code snippet here in my machine. I have installed the JSON Web Token, a vulnerable version. So let me verify that. So I'm simply using the command npm list. So it will be listing all the installed npm packages. So let me go to this npm list. I'm just executing this from the home directory. Now you can see JSON Web Token version is 8.5.1, which is the infected version that's been installed in this machine. And I can simply test this vulnerability from my machine itself. So let me show that. But before that, let's see the source code. JSON Web Token. So you can see the JSON Web Token package files here. So these are the JavaScript files, and the file we need to see is the verify, because the vulnerability found in the verify.js file only. So I will use nano in order to show this file to you, -L I guess, to read the line numbers. Yeah, so here is the file, and I'm simply scrolling down, and you can see the list of algorithms given here at the header. And if I scroll down further, I would be seeing the same code snippet that is given in that blog. Let's see that. So yeah, here is the code snippet. If options algorithms, any one of these algorithms, so index of begin certificate, if it is a certificate file, or if it is the beginning of, it is a public key, or if it is the algorithm of the mentioned algorithms. I mean, look at these algorithms mentioned here: public key algorithms, RSA key algorithms, the list of algorithms given here. So it verifies whether the algorithms given in the list, so it verifies the list, the algorithm list, which algorithm is used. And when no allowed algorithms are provided within the options algorithm list, the value within the privacy enhanced mail file, which is provided by the secret or public key parameter, will be assigned instead. So this is the very important part. This is what causing the vulnerability. I'll try to explain this. I'll clarify this. I think I have confused this a bit, so I'll try to clarify it. So here you can see the list of algorithms given here. The third part is nothing but, the third argument of this function is nothing but the options. The options is containing the list of algorithms, and the list of algorithms is given here. It is also given in this package verify.js. And the third option is simply verifies which algorithm it is. The third argument, this option argument, it verifies whether it is RS256, RS384, RS512, or any of these three, or any of these three. It verifies this one. Here the issue arises when the options, I mean the algorithms, are not given. So that's what they have mentioned here. And when the algorithm is not given, it is actually assuming the algorithm from the PEM file, actually that is given to the second argument, secret or public key. So you can see from this documentation here, the secret or public key is actually containing the, it's a string or buffer, they mentioned that clearly, and it is containing the HMAC algorithms, PEM encoded public key for RSA and ECDSA. So even this secret or public key is giving some sort of algorithm, some cryptographical algorithms. So what happens when the absence of algorithms argument, it is actually considering the content of the secret or public key as an algorithms. So that is what they are trying to say here. This presents a problem. So there is no check in place that the secret or public key is actually a valid PEM file's content, and this unverified object toString method is blindly being used. And you can see the toString method is given here, used within this secret or public key stuff. So when this scenario happens, there is no check in place that secret or public key actually a valid PEM file's content. So this is what causing the problem. So attacker with control over this object can supply their own toString method, which will then be executed by JSON web tokens verify in line 114. And you may see this specific line here, JSON web token verify. So this is the code snippet belongs to this verify method. And when this, the verification, there is no check in place for this second argument, the attacker can supply any string within this method and they will be able to execute that. So that is what causes the remote execution. So they also gave the same remote execution stuff in a proof of concept. So we can simply work it out with the node interpreted, the node, interactive or node environment interpreter. So let's try to work out. So I'm exiting it. So let me go for node environment. So I'm in the node environment now. I'm using the Node.js 18.12.0 version, and you can see the POC here. So let me replicate the same stuff. So I'm giving a variable JWT, and I'm calling the library require with require method, and inside the single quote I'm mentioning the JSON web token library. and I am ending this line with the semicolon. Now I have called the JSON web token, and you can see there are some the message, so which contains the list of methods available, the list of functions available within this library, and also some error handling statements, I suppose, error handling function. Okay, now we called this library. Let's mention the token. So we are going to generate some random token here. We don't have any web application, so we are simply generating a random token. So I'm calling this JWT. So that is what the object name here, and also the method I'm calling dot sign. So sign method is used to create a token. So here I am putting a curly braces, and inside a double quote I'm mentioning x, one colon, once again a double quote, within that I'm mentioning y. The xy's are nothing but simply the username and password, you can say, and I'm closing this curly braces and separating with comma, and there is a secret string. So the secret string can be anything, so I'm simply using the same thing they have used, some secret, so it can be anything, any word. So this is the secret I'm using in order to sign this token, and I'm closing this line and typing, and you can see the JWT has been generated. So this is the JSON web token. Well, going to the next line. So this is what the important thing. So here we are creating the malicious object. So we are creating the specific code that has to be executed, and we are assigning it to a malicious object, and that's what they are mentioning here. That's why they are mentioning it here, mal underscore object, malicious object. All right, now let me type this whole line. So it is a bit hard to me as I am not a JavaScript person. So I'm simply copying this obj, and I'm opening the curly braces here, and I'm calling the toString method, because this is the method is holding the vulnerability, the flaw, and I'm putting the semicolon, and I'm closing the bracket, an empty bracket, and equal some redirection sign. I'm not sure what it is, but I'm giving it. So curly braces opening again, console.log. Console.log is equivalent to print, which is going to print certain strings for me. All right, pond. So I'm displaying a message here. The message is nothing but pond. All right, I'm closing the bracket and semicolon. Fine. Now I am using process.on and exit. I'm calling a process method on exit. I think I'm mentioning to execute certain stuff. So let's do that. On exit, I'm again putting one empty parenthesis, redirection, opening another curly braces, require, and here I'm calling the file system library, I suppose, and dot write file sync. That is the function, write file sync. All right, and now I'm mentioning the file name to create. So what actually it does, so we are going to create a file called malicious.txt, which will be containing this specific string that they have mentioned here. So we are going to mention the file name and also the file content. So the file will be created once you execute this malicious object, and we are going to execute this malicious object with the verify function. So that's what we are going to do. And malicious, all right, .txt, the name can be anything, it is up to you. So I'm giving the same name, and again opening the bracket to mention the content. Hi everyone, please subscribe to Perumal Jagan. So I gave my message here and closing the bracket, semicolon to end the line, and curly braces and one more bracket. So there are a lot of bracket, I shouldn't make any mistake here. All right, closing with another semicolon, and now the final part, process dot exit, and here I'm giving 0 within the function, and closing it with double curly braces. Well, let me verify this. Malicious object toString colon empty bracket, redirection, console.log pond, process on, exit, comma. Okay, I made a small mistake here. I shouldn't have added that bracket after exit. Okay. After exit, okay, there is one more empty bracket, redirection, require fs dot write file sync, and within that malicious.txt is one argument and the file content is the next argument. Closing the bracket, ending the line, ending the sentence, ending the function, and the curly brace, parenthesis, semicolon, process.exist, exit 0 within the exit function, and closing it with two curly braces. Well, looks okay now. Let me enter this undefined. Okay, I'm not sure what happened, but let me call this one, call this verify function JWT dot verify, and within verify I'm getting token we have already generated here, and the malicious object mal obj. All right, now I'm giving this, look at this, I got the status like pond. It gave me the pond string that is we have mentioned in the inside the console log function, and now I am seeing the current directory. I should be getting the file called malicious.txt. Look at this, ls-la malicious.txt. So let me list that file, and you can see the file creation time is around 4:57 p.m. and that is the time the file has been created. Let's see the content. Yeah, this is the content that I have given into this function, toString function. Well, yeah, now we have seen the code execution, but you can ask a question how it can be exploited in exploited by an unauthenticated attacker who accesses web applications from outside network, who doesn't have access to this verify or who doesn't have access to this machine which is running the JSON web token hosted the web token web application. That's the valid question, and that is where they have given the update. Even I had that questions when I was reading that. Let's try to understand that as well. But before that, here you can see there is another malicious object they have created where they try to create a directory called pond and with the child process. So looks like the same code execution, but they have tried some other things with different malicious object. Anyway, it is going to happen because the verify function is vulnerable inherently. Well, all right. Now you can see the exploitation prerequisites. Actually, this prerequisites was given during the early release itself, but let's read through this. In previous sections, we have demonstrated how a poisoned secret key could lead to an RCE. In reality, keeping and maintained secret keys usually involves secret managers, secret key rotations, encryption, or other best practices. In order to exploit this vulnerability described in this post and control the secret or public key value, the attacker will need to have control or exploit a flaw within the secret management process. Yeah, so this is the important part here. They confessed, they admitted that the attacker need to have the control or exploit a flaw within the secret manager. And even then the exploitation might be complicated as the output of the secret manager is uncertain. So that's what they are trying to say here. And it can be the type of not suited for an exploitation and or many other possible scenarios. So they clearly mentioned it would be very, very difficult to exploit, and also it will be a meaningless one. Due to the complexity of the exploitation of this vulnerability, they actually trying to give CVE score of 6.6, but eventually they decided to 7.6. But this doesn't matter because they now revoked this. They now retracted this, the entire CVE, the entire flaw. Now let's get into this fix part. So here is the fix. So in the recent 9.0 version, they have modified this whole code block. So that is actually not having the control over the secret or public key parameter. So this code is vulnerable one. So they replaced this code and they have added this specific stuff in order to verify the secret or public key and its authenticity. Well, so this is the fixed code, and the vulnerable code was removed and replaced with the checks of the, checks for the types of secret or public key parameter. So here it strictly checks for the type of secret or public key. So it makes sure it is a string, and which prevents the secret or public key from containing malicious objects. Well, they have fixed it, but however, let's see this timeline here. So actually the unit 42, the one who found this flaw, and they reported it to Auth0 on July 13, 6 months back, and they took till December 21st to patch this flaw, and it happened for around 6 months. Now the final part, let's get into the latest update that is launched by Auth0. Now let's see this update. After hearing the community feedback about the prerequisites of exploitation scenario of this vulnerability, we made the decision to work with Auth0 to retract CVE-2022-23529, and which means this vulnerabilities no longer exist. And the security issue described in this blog remains a concern when the JSON Web Token library is used in an insecure way. So this is a very important point. In that scenario, if all prerequisites are met, this issue may be exploitable. We agree that the source of this risk, this case will be in the calling code and not in the library. So they clearly mentioned it. The source of this risk is the calling code only, which means the malicious objects we have created. Here the risk is this malicious object only, not this library. So that's what they are trying to say here. And the important security checks were added in the JSON Web Token code to address this issue. They are also recommending to patch this to the latest version. And let's read the official Auth0 GitHub repository, where they have clearly mentioned this recent update. What are all the aspects of this recent update? After review and validation of the community feedback regarding the viability of exploitation, it was determined that due to multiple prerequisites required for successful exploitation, a CVE was not warranted, and therefore decision was made to retract CVE. And the security issue remains a concern only when JSON Web Token library is used in an insecure way. In such scenario, if all prerequisites are met, the issue may be exploitable. However, the source of this risk is the calling code and not the library itself. So they have clearly mentioned that. And in the version that is less than 8.5.1, less than or equal to the JSON Web Token library, the malicious actor has the ability to modify the key retrieval parameter. This one, because this one was modified by the by us a while ago, and we have created a malicious object and we have executed it with the help of this secret or public key toString function. And arguments from the readme link. Okay, if a malicious actor has the ability to modify the key retrieval parameter of the JWT verify function, they can gain the remote code execution. Now here is the final part. They explained it clearly. This security issue is a concern when JSON Web Token library is used in an insecure way. The same line. Users are affected only if they allow untrusted entities to modify the key retrieval parameter of JWT verify. Well, this one is this one will be a heavy risk. This one will be a severe one when the attacker, the adversary, gain access to the key retrieval parameter of the JWT verify function. Because in order to exploit this vulnerability, they need to gain access to this source code of this library. So I think that is what I'm getting from this. In this scenario, if all the prerequisites are met, the issue may be exploitable. The source of risk in the scenario would be in the calling code and not in the library itself. That's why they have retracted this vulnerability, and you can fix this vulnerability by upgrading it to 9.0 version. Well, yeah, this is what I was thinking to explain. Actually, it was created a lot of speculations, in the community also. So I hope you have learned something new from this. You have understand this vulnerability in a better way through this video. If you really learned something new, you can consider subscribing my channel and ring the bell to get notified whenever I am posting a video, and I'll share the relevant links in the video description so you can access this blog and you can read and understand more about this. And yeah, if you have any other opinion, put it in the comment section. I'll try to read and answer your valuable questions, and please share your video among your friends. I'll catch you next time with another exciting video. Until then, I'm signing off. Cheers, and I love you all. Thank you so much.